Next one is chemical properties. First one with nitration mixture. Reaction with nitration mixture. So nitration mixture means it is a concentrated H2SO4, concentrated HNO3. So it's going to be give that electrophile NO2 plus. It will be attacked on ortho and para position. OH is ortho directing group. OH is ortho and para directing group. OH is ortho para directing group for electrophile attacking. For electrophile attacking or OH is ortho and para directing for nucleophile meta directing. So it's going to be from ortho and para isomers of phenol. I'm reacting with this one is PCl5. What will happen? Alcohol is going to be reacting PCl5 means what will form? Alkyl chlorides, alkyl halides will be formed. Here chlorobenzene is going to be formed. Remaining is HCl plus POCl3. That one with doing with zinc dust. Zinc dust, it is going to be called reduction. Going to be happen reduction. Reduction or it's going to be remove that oxygens. It's going to be form reduction reaction. It forms benzene. So if it is reacting with ammonia in the presence of anhydrous zinc chloride. Zinc chloride is the dehydrating agent. Dehydrating agent means it's going to be taking removal of water. It's going to be formed. So removal of water means and from phenol H will comes. Sorry, phenol from phenol OH will comes. From ammonia it comes H. So loss of water remaining from NH3, NH2 will be there. That is going to be attacking here. It forms aniline. It forms aniline. So next one is sulfonation. If it is reacting with sulfuric acid, sulfonation is going to be takes place. Sulfonation. How can you write that H2SO4? We can write H2O plus SO3. The phenol is ortho directing group. For example, if you are taking a phenol, this bond electrons are going to be shifted to this side. These electrons are going to be shifting negative charge on ortho position. If negative charge is going to be shifted to this side, this will be forms negative charge on para position. Again, this one is shifting. These electrons are shifted to ortho position. In which positions we are getting negative charges? are the positions. Means we can add positive charge on are the positions, right? Electrophile we can add in this position, and this one also. Why? Because there only negative charge is present. Negative charge is present means there only we can add positive charge. Electrophile. Where we can add a nucleophile means we can add in this place, meta position. Meta position we can add nucleophile. So for electrophile, it is a ortho and para directing group. OH is so from this one H2 SO4 is there. SO3 is there. Here SO3 is the SO structure is this one is double bond O, double bond O, double bond O. Oxygen is going to be shifted to this side. So sulfur is going to be get a positive charge. Means this one is electrophile. So benzene to ring. The double bond is going to be attacking on sulfur. This is going to be shifted to this side. It is going to form negative charge. So after doing the protonation, it's going to be converting of HSO3 directly attacking on ortho position and para position. Here OH, here SO3H, ortho. Next one is OH, and this one is para position. Reaction with thiols. Benzoylation means introducing of benzoyl group. What is a benzoyl group means? C double bond O. This group is benzoyl. This group is benzoyl. This group we need to introducing on phenol. That is called as benzoylation. Next one is thiols. Next one is hydrogenation. So if you are saying this one, benzoylation means this one is C6H5. On benzene, we need to introducing of C6H5 C double bond O. This is called as benzoylation. So I'm taking benzoyl halide C6H5 CO Cl I'm taken. It is thiol. This one is hydrogenation means I'm taking H2 in the presence of nickel, platinum, palladium. Hydrogenation means adding of hydrogens, reduction this one. So benzoylation means what will happen? So benzoylation means it is going to be I'm taking phenol and also I'm taking benzoyl chloride. Benzoyl chloride I'm taking. So from this what will happen? It's going to be loss of HCl. It's not going to be taking. Why? Because this is the ortho and paradiating group. This ortho and paradiating group. Here hydrogenation will be there. Or one more possibility. These bonds are going to be shifting this side. This one is going to be shifting that side. Means negative charge will be forms on ortho position. This will be going to be attacking on this carbon. Why? Because this carbon is electrophile. This one is going to be shifted towards oxygen. Means this one carbon is going to get a positive charge. So this is an electrophile. After moving off towards oxygen electrons, the electrons are going to be come back. This Cl is going to be leaves. Then what is the final product? First take the above one, phenol. I'm taking phenol. That phenol, this are the positions attacking on carbon. C double bond O, benzene group. So that is benzoylation. Next, thiols. Thiols nothing but phenol is going to be reacts with thiol. It is going to be replacing of sulfur by oxygen. That oxygen is going to be shift, replacing of sulfur. It is going to be forms thiophenol. Yes, H. Thiophenols are going to be formed plus C2H5OH. This one is called as thiophenol, replacing of sulfur by oxygen. Next one is hydrogenation, means adding of hydrogens. Reduction will be take place. In the presence of nickel or platinum or palladium, it's going to be reduce that double bonds. It is going to be reducing the double bonds. How many double bonds are there? Three double bonds are there. I am taking 3 moles. If you are taking any 1 mole, it is going to be reduced one double bond only. If you are taking 3, it's going to be adding of hydrogen, hydrogen. The bond is going to break. If I want this break, here one hydrogen, hydrogen, breaking. Here one hydrogen, hydrogen. Adding of hydrogens we can call as reduction. So it's going to be formed cyclohexanol. Cyclohexanol is going to be formed. Acylation. What is Friedel-Crafts acylation? Introducing of acyl group. This is the CH3 C double bond O is the acyl group. That acyl group we need to introducing on benzene or phenol, that is called as acylation. So the reaction we can call as Friedel-Crafts acylation. Friedel-Crafts acylation. Friedel-Crafts acylation. What will happen? The negative charge which is formed on ortho position, it will be attacking on carbon. This will be go up and it will coming back. Cl is going to be used like benzoyl chloride. On benzene, OH is going to be taking off. Ortho position is attacking to C double bond O and CH3. This is called as acylation. Adding of CO CH3 is called as acylation. Maybe this is acyl group. That is one of the name reaction for Friedel-Crafts acylation. Next one is alkylation. Alkylation is nothing but we need to introducing of one alkyl group on benzene like acyl. In the place of C double bond CH3, we are going to be adding on CH3 group or any alkyl group, that is called as alkylation. Same reaction, but it is introducing of alkyl. So we can call this one is Friedel-Crafts alkylation. Friedel-Crafts alkylation. So I'm taking here CH3Cl. So from this one, it is going to be negative charge or this hydrogen and this Cl is going to be lost out. It's going to be forming of OH. This one is CH3. It can be possible ortho and para group also. Para positions also will be possible. But one is major, one is minor. Both will be possible. Ortho and para positions of isomers. I am giving only one. So that is Friedel-Crafts alkylation. Next, Mercuration. I am taking mercuric acetate. CH3, COO, CHG, OOCCH3. Mercuric acetate I am taken. Mercuric acetate means mercury is positive charge. It is plus 2. This is minus minus. So mercuric acetate I have taken if you are reacting with the phenol. What happened? It's going to be shifting this side. Negative charge attack on mercury. This one is going to be go out. What will come out? CH3, COO, minus will be comes out. That minus will be going to be attacked by this hydrogen. It's going to be formed CH3, COO, H. This remaining part, Hg, COO, CH3 is going to be attacking on benzene. That is called as mercuration. OH here, Hg, COO, CH3, mercuration. Argon para positions. This one is OH. We can add right here Hg, O, O, C, CH3. Argon para positions of groups are going to be possible. Next, Kolbe-Smith reaction. Phenol reacts with iron chloride. We are going to be use this reaction to test if phenol is present in the solution or not. Testing of phenol. While in the product, phenol molecule is there or not, we are going to be checking by the adding of FeCl3. If phenol is present, that phenol is going to be react with the iron chloride. Is going to be form a violet color complex. The violet color is going to be formed due to the formation of iron complex. How it is going to be forming means Fe. We have the phenol. We have phenol. It's going to be formed phenoxide ion. After releasing of H is going to form phenoxide ion. This phenoxide ion is -1 charge is there. So iron, this one is iron is +3 oxygen state, chlorine is -1. It's going to be forming one complex O. It will be 6 times -3. So due to the formation of this iron complex, the complex is going to be showing violet color. Violet color is going to be showing. If it is violet color, it will forms the solution having contains phenol. Testing of phenol. Next one is ether formation. Ether formation, or we can call it as Williamson synthesis or Williams synthesis. Williams synthesis means we are going to be needs to forms that ether molecules. O CH3, CH3. This is we can call it ether, or a place of pH you can take PHO CH3. This also ether. We need to form the ethers by reacting of phenol with the other molecules. If you observed in the above molecules, Friedel-Crafts acylation. What is the type of reaction it is? What is the type of reaction? So if you are taking that phenol, so we need to form ethers by phenol is reacting with other molecule, it's going to be form ethers. I'm reacting with CH3Cl, and also I'm reacting with dialkyl sulfate, dialkyl sulfate, and also I'm reacting with alcohol in the presence of heating and thoria. In the presence of heating and thoria, the resultant product is going to be formed is ether. This is called as Williamson's synthesis. So from here, it is going to be loss of HCl. It forms OCH3. From here, again H. For this one here, 2 moles are there. We can take 2 moles of phenols. Two hydrogens are coming out. One SO4. It's going to be forming H2SO4. Byproduct is H2SO4. Then here on place of H, what's going to be adding? C2H5. OC2H5. We are going to be taking 2 moles. Why? Because two alkyl groups are there. Two alkyl groups are going to be substituted by hydrogen that is called to forms ethers. Next, this one is alcohols. It's going to be released at OH. It's going to be releasing H. It forms OC2H5. So it is also formed alcohol ether. The name of this one is ethyl phenyl ether. We need to write that alkyl questions what are attached to ether group. After we need to give the name is word ether. So this one is methyl phenyl. Which one will come first? Methyl phenyl ether. This one is ethyl phenyl ether. Same product. That is called as ether formation. Next one is reaction with acid anhydride. Phenol I'm taking. Phenol is reacting with acid anhydride C double bond O C double bond O CH3. It is acid anhydride. So the phenol is going to be argon para-directing group for electrophile is going to be attacking on carbon. This bond is going to be shifted to oxygen. So that one is going to be attacking on phenol COH here C double bond O CH3 plus remaining is CH3 COO CH3 COO. It forms acetic acid. Next one is coal base or coal base Smith reaction. Coal base Smith reaction. So coal base Smith reaction means it is going to be introducing of one carboxylic acid group on benzene or phenyl group. That is called as coal base Smith reaction. It is going to be formed in the presence of CO2 at low temperature, and it's going to be taking place of pressure is 4 to 7 atm. The phenol is going to be reacts with carbon dioxide in the presence of chloroform CHCl3, and the temperature is 405 to 413. The pressure is 4 to 7 atm. Under these conditions, the phenol is going to be reacts with the CO2. It is going to be forming of OH, and ortho question which forms carboxylic acids. Here CO2 is there. C double bond O and double bond O. It is going to be, this one is attacking on this position. This is going to be most to oxygen. So what will form here? C C O O. C O O will form after the formation of O. This hydrogen will present here. That hydrogen is going to be migrated to this oxygen. It's going to form carboxylic acids. Next one is Gutterman reaction. Gutterman reaction is nothing but the phenol is going to be reacts with hydrogen cyanide in the presence of HCl gas. Under acidic hydrolysis, it is going to be converting into aldehydes. Benzaldehydes are going to be formed. Orthohydroxy benzaldehydes or parahydroxy benzaldehydes are going to be formed by this reaction. So, what are the needs are going to be required to form this Gutterman reaction means we are going to be taking one is phenol, so it is going to be reacts with hydrogen cyanide. First I take hydrogen cyanide HCN reacting with HCl gas, reacting with HCl gas in the presence of anhydrous AlCl3. In the presence of AlCl3, we are going to be reacting with hydrogen cyanide and HCl. So what will happen here? This AlCl3 have vacant orbital that is going to be attacking of the Cl minus will be attacked to AlCl3. It forms AlCl4 minus will be forms. So what will be there here remaining? H plus is there. That H plus is going to be attacking by lone pairs of nitrogen. What will form here? H, C, triple bond, N, H. This one is the positive charge. On electronegativity atom, positive charge means unstable. This bond is shifted to that side. It is forms H, C, double bond, N, H will form. Now carbon is lost electron. Then carbon forms positive charge. After the formation of this charge, it is going to be reacts with the phenol. Take that product CH plus double bond NH. This will be formed after the formation of this one is going to be reacting with the phenol. Now we know this one is argon paradiating group. I am reacting with the paradiating with the here to the carbon. What will be formed here? Here OH, here C is there, and H double bond NH. Amine group is going to be formed. After the formation of amine, I am doing hydrolysis. Doing hydrolysis means first this one is going to be break. Which one is electronegative? Carbon or nitrogen? Nitrogen is more electronegative. So positive charge will be attacked on this side, H. This side will be OH. Doing hydrolysis, adding of H2O. If I break this first one, positive charge will be attacked to nitrogen, negative charge will attack to oxygen. Second bond also I am breaking. Again H, OH. Or we can add directly. To see that product now, what is formed here? We are doing hydrolysis in the presence of acidic medium. If you break the two bonds, carbon side two OH groups and nitrogen side two H1s are going to be formed. Means loss of NH3 and remaining product is this one is OH, then that one is CH, OH and OH. Form two moles of OH groups on same carbon. On same carbon, two hydroxyl groups are formed means that is molecule is stable or unstable? Unstable. It is going to be taking loss of water. Two OH groups are present on one carbon. It is highly unstable. That is going to be taking place of one loss of water. The remaining product is OH here, CH, and one oxygen is the benzaldehydes. We can call this one is on para position, hydroxy is there, para hydroxy, benzaldehydes. Para hydroxy benzaldehyde is going to be formed if you are taken hydrogen cyanide in the presence of HCl gas and anhydrous AlCl3 reacts with phenol. Now, if you observe here, if you hydrolysis this molecule, if you hydrolysis this molecule and get breaking that double bond to add two water molecules, what will be formed finally? It is comes O. This side nitrogen side, two hydrogens are added. We can directly add here O and H2. No need to go with this step. Loss of forming of two hydroxyl group and loss of water. From that step, we can write directly CHO and NH3. Water molecule H2O, we can write O on this side, 2H plus R this side. Raman Tiemann reaction. Raman Tiemann reaction. So here phenols are going to be react with chloroform in the presence of base. It's going to be forms ortho benzaldehydes. Ortho positions of groups are going to be formed. Getter one is going to be formed. Para position is major, but this one is going to be taking place of ortho. I am taking phenol is reacts with chloroform CHCl3 in the presence of base. I am taking NaOH. What will form? It is going to be formation of OH and this one is CHO. Ortho hydroxy benzaldehyde will be forms. Ortho hydroxy benzaldehydes are going to be formed. So we are seeing that mechanism. First, I am taking with the base and chloroform NaOH plus CHCl3. So it's going to be released at H plus. It's going to be releasing OH minus. It forms H2O plus CCl3 minus. So from this Cl minus is going to be comes out by reacting of Na. NaCls are going to be come out. Remaining is CCl2, 2 electrons. We can call this one is dichloro, dichloro methane, methane, or we can call as carbene, dichloro methane, carbene, dichlorocarbene. So general name is we can call this one is carbene. On one carbon, two free electrons will be present. That one is we can call as carbene. So that carbene is going to be react with phenol. That carbon is going to be comes and react with the phenol. Carbene also we can take it as electrophile. Carbene also an electrophile. So that lone pair of electrons of carbene is going to be attack on this position. This is going to be shifted to this position. What will happen here? It's going to be forming of O minus. It will be CCl2. And here hydrogen is there. That hydrogen is going to be attacking on carbon. It forms CHCl2. Do that protonation. It's going to form ethanol. Sorry, phenol. It will be CCl2. CHCl2. After the formation of CHCl2, I'm taking one aqueous NaOH. Aqueous NaOH means what will happen? I'm taking base. Base will be gives OH minus ions that will be replaced two chlorines on carbene. It's going to be replaced these two chlorines by two OH groups. Here OH I am there and CH it will be OH. This also OH. On one carbon presence of two OH groups. Not stable. Again taking loss of it's going to be forms OH. This one is CHO. This one we can call as orthohydroxy benzaldehyde. Orthohydroxy benzaldehydes.